Welcome back. This is our last lecture on audition. In the next two mini lectures, we'll talk about perceptual organization. But I wanted to end our segment on audition by talking about hearing loss because it's something that many of us experience. One sort of problem that you can have with your auditory system is a problem called tinnitus, or ringing in the ear. Tinnitus happens when your ears are telling you that there is a sound outside in the world, but there is no sound out there in the world. I'm experiencing it right now. It's like a humming in my ear. I experience it because I do not have particularly good hearing. Sometimes what happens is if you have too many damaged hair cells, and remember it's the bending of the hair cells that causes action potentials to travel up your auditory cortex to the brain to tell the brain there's something happening, there's some noises in the outside world. For those of us who have damaged hair cells, there aren't a lot of signals coming in from many of the hair cells, right? If my hair cell's damaged, those hair cells cannot send signals to the brain. Now, my brain can draw one of two conclusions from the absence of action potentials coming in from the auditory nerve, or action potentials about particular pitches or frequencies. It can conclude that there are no such pitches in the world, or that they really are there and I just haven't detected it. Yeah. So tinnitus means my brain is saying, but there must be sounds at that frequency. Well, so it fills them in all the time. So tinnitus is when you hear sounds in an environment that is completely quiet or completely without sounds. The causes we know are typically hearing loss, although some medications can cause tinnitus. It is pretty common, as you'll see later. Okay. Another type of hearing loss, actually two categories of hearing loss proper, are conduction hearing loss and sensory motor hearing loss, or nerve deafness. Conduction hearing loss is when there's something wrong with the mechanical part of your ear, that is the transference of air pressure waves into your ear. So for example, at the end of the auditory canal is the eardrum. For us to hear, that eardrum has to be pushed in and out. When I was a kid, Q-tips would have an ad saying that you should use Q-tips to clear out the wax, the buildup of wax in your ear canal. Now, the wax is something that your body's developed over evolution to clean out our auditory canal in case any dirt or bugs or something get stuck in there. The earwax is a way of clearing it out. But Q-tip sold itself as a way to clean out the earwax. And the problem is if someone took a Q-tip and stuck it in their ear canal longer or farther than was the space available, they could stick the Q-tip right through their eardrum. And that's documented here. If you've got a hole in your eardrum, you can't hear. It would be like taking a drum and cutting the top of a drum out. If you do that, it's not going to work because the membrane's not going to be pushed anymore by the pressure. The pressure is just going to go through the hole. So I should say Q-tips no longer has commercials selling itself as a way to clean out your ear. Because it's so dangerous. In fact, now they have an ad on their packaging saying, do not stick these things in your ears for the reasons that you see in the picture here. Sensorineural hearing loss or nerve deafness is when you lose hearing because the cable connecting your ear to your brain, that is your auditory nerve, has some problem with it, right? So there could be a problem with the mechanics of the ear itself, or there could be a problem with the nerve that connects your ear to your brain. Either one of those problems is going to cause hearing loss. Hearing loss is very common. It's increasingly common. It's the most common disability that soldiers come back with. It turns out that If you happen to be in a room where there's a hand grenade happened to go off, or a building that a hand grenade went off in, those are extremely loud, and it kills hair cells immediately, and they don't grow back, unfortunately. But you could be working with very loud, heavy equipment. That could cause permanent damage to your hair cells, and so permanent hearing loss. It's not bad enough that you have hearing loss, but for many people who have hearing loss, they end up getting that tinnitus, or ringing in the ears. And the ringing in your ears can be so disturbing that there have actually been cases of people who commit suicide because they cannot stand the sound anymore. We don't have a really good treatment for tinnitus. There are apps on your telephone that can sort of mask it, or mindfulness meditation, that is directing your attention away from the sound, are the sort of common treatments for that particular disability. Hearing loss also increases with age. So on this graph, on the vertical axis, you can see the prevalence, or the percentage of people who have hearing loss, and on the horizontal axis is the person's age. And you can see that very few young people have hearing loss. It's a pretty small percentage, maybe 2%. If you get up to be my age, so I'm in my late 50s, about 12% of us have hearing loss. When someone gets up to be in their 70s, about half of them have hearing loss. Because of the relationship between exposure to loud noises and hearing loss, many people pay very close attention to loud settings, and they make sure to wear ear protection. Headphones, earplugs, and earplugs are recommended for extended exposure to any sound over 85 dB, or 85 decibels. So if you love playing music really loudly, enjoy it now, because you're not going to be able to do it so much later, right? I know people, I did it as a kid too. It just feels so cool to drive around with this loud music out of your car. Well, that coolness that you have as a kid means you've got hearing aids when you get to be my age. Ambulances, gunshots, fireworks, all of those things, you really shouldn't be around them without earplugs or fancy versions of ear protection, because otherwise you're going to spend a good chunk of your life saying, "What? Excuse me? You're mumbling." My father had hearing loss. My whole childhood, I thought I mumbled. It's like, no, he just couldn't hear me. Now, it turns out that this is interesting, especially for older couples, heterosexual couples. Hearing loss with age isn't uniform. So we tend to maintain our auditory sensitivity to low frequencies and medium frequencies. Where you see the big decrement, the big loss in hearing, is with the higher frequencies, the higher pitches, right? So by the time somebody is 60, a high frequency tone has to be 100 times louder or higher for somebody to hear it. Now, why did I say that's interesting for couples? Well, men have lower frequency voices than women. Women tend to have higher frequency voices. And in my family, hearing loss runs in my family. And older couples, it's hysterical. You see the same fights all the time. The wives feel like the husbands aren't listening to them. Why might that be? Well, it may have something to do with my family, which is its own course in psychology. Or it may have something to do with the fact that women speak at a higher pitch, and that's exactly what we lose sensitivity to the hearing of higher pitches. That's exactly what hearing people lose as they get older. So anybody out there who's a little frustrated with older people not being able to hear them, just speak in a lower tone, and they should be more likely to hear what you're saying. Some people have taken advantage of the hearing loss that comes with older age by creating systems that will drive younger people crazy because only young people can hear them. Yeah, it's true. Some company that has a speaker that emits a high frequency sound that young people can hear, teenagers and 20-year-olds, but 50, 60, 70, 80-year-olds can't hear. Sometimes this buzz is called teen buzz or mosquitoes. Sometimes really smart young people set their text alert sounds or their phone alert sounds not to a ring, but to this mosquito or teen buzz that they can hear, but their parents can't. Tricky, right? Nerve deafness. There is treatment for nerve deafness. It's called a cochlear implant. And you can see in the upper picture here what the inside of a cochlear implant looks like. Basically, sensors are placed inside the cochlea along the basilar membrane inside the cochlea to do the job that the hair cells in the basilar membrane would normally do. And on the lower picture, you can see a young boy who has a cochlear implant, and that's connected to a hearing aid that allows him to hear. Now, about 100,000 people worldwide, probably more by now, use cochlear implants. So these are deaf people who can now recover some hearing even though their auditory nerve is damaged, right? So in deafness due to a damaged auditory nerve, you can circumvent the auditory nerve as happens here. So you might think, well, why in the world would using a cochlear implant why would anybody have a problem with that? It's really interesting. What's wrong with being deaf? So those of us who are hearing might think, wow, being deaf, not being able to hear, that must be terrible. But deaf people will tell you, not really. We're fine. We have our own language, right? We have a rich culture. We're not disabled. In fact, you, hearing people, are disabled. Now, why do deaf people think that hearing people are disabled? This is cool. Imagine you're deaf. Your auditory system might not be getting a lot of stimulation. And so your visual system looks over at all that untapped computing power and says, ooh, I'm going to take some of that. So essentially, deaf people have bigger visual brains. They have more extensive processing capabilities when it comes to analyzing incoming visual information. What's the result? Deaf people see better than hearing people. So this is called sensory compensation. When you don't have one sensory system, your other sensory systems compensate by becoming stronger. So deaf people will tell you, we don't have a disability. No. We have vision enhancement. You're the one with the disability, which I love, right? Because it's a great example of how we're all wired differently. And it just doesn't make a whole lot of sense to say that one wiring or one brain is better than another. That's it for audition. Come back and we'll talk about perceptual organization, and I'll show you all sorts of cool illusions. Come right back.